7th grade. So today we're going to be in Module 18. I apologize for this. In your PDF lessons, it'll say Module 7 because if you recall, when I made these slides, we only had access to the 8th grade textbook instead of the 7th grade accelerated, so it's the exact same material. It's just written as though it's the 7th module in the 8th grade book instead of the 18th module in the 7th grade book. Okay, so we're going to work on solving linear equations, which you have done already, but these are going to be a lot more complicated. So most of you did a really good job with solving equations during the year, so I'm not really too worried, but make sure you do watch these videos and at least check your answers to make sure you're doing them correctly, because these are more complicated than the ones that we did at the beginning of the year. So to start off, we're going to learn how to solve equations that have variables on both sides of the equal sign. Then we're going to move on to solving equations with rational numbers. That just means that we're dealing with fractions. And then we're going to work on solving equations that have to do with the distributive property, which is actually kind of fun. And then the final lesson in this module is going to be looking at equations that have infinitely many solutions or no solution at all. I did include the link for you guys to watch your real world videos since I know you love them so much. So you can take a look at those if you'd like. So before doing an example, what I wanted to do was give you guys some steps to follow, because this process, if you follow it the same way every single time, you will have a little more success in solving them. Now, you can solve them in different ways, but those of you who prefer some routine and some structure when you're dealing with problems, if you follow this way every single time, you'll always get the right answer, and you won't have to be really thinking about how to do it so much. You'll just be kind of following, the same type of a routine each time. So I'm always fine with you guys solving it, in a different way, but I just wanted to give you steps because it might help some of you. So the first thing is that you want to draw that line through the equal sign to separate the sides of your equation. When we're dealing in this module now, they're going to be, like I said, they're much more complicated. So it's going to be a little bit harder for you to see what's on which side of the equation. So I do suggest drawing this line. After you do that, we're going to look on each side of the equal sign and see if there's any like terms to combine on that side of the equation. Because before we start moving things around using our inverse operations, everything has to be fully simplified. Okay, so we want to look on both sides of the equal sign and make sure there's no like terms. If there are like terms on the same side, then you want to combine them before you move on. The next step is going to be to move any variables that are on the right to the left. I want all my variables on the left so that I can solve for my equation. Then we're going to move any constants that are on the left to the right, and then we just solve as usual. Okay, so this might not make sense right now until we actually use the steps. So what I'm going to do is I'm going to keep the steps to the side while we do the first example. Okay, so, oops, I forgot a page, hold on. Sorry guys. So this is what these equations are going to look like. It's really not bad. It's just that there's variables on both sides. So step one was to draw the line through the equal sign, right? So I can separate and see which side is which. My second step, check to see if there's any like terms on either side, and if there is, combine them. So I'm talking about one side at a time. On this side of the equal sign, there's nothing to combine. And on this side of the equal sign, there's no like terms. So I'm going to proceed with my steps. Step 3 is to move any variables that are on the right to the left. So I look on the right side, and I do have a variable here. I want all my variables on the left so that when I solve this equation, it's x equals a number. So I need to move this x, this negative x, to the other side. So I'm just going to do inverse operations. This is a negative x. So I'm going to add x so that this cancels out. And what you do to one side, you do to the other side. So when you do this, you have to line it up with the like term, right? If I'm adding x, I need to add it to the other x. I'm not going to add it to the 4 because I don't know how to do that, right? Okay, so I'm just gonna reset my equation here. X plus x is 2x. Bring down your plus 4 is equal to, and now I have this 4, but look what's attached to it, it's a negative. So make sure you don't forget about that negative 4. Okay, and that's what my equation looks like now. Step 4 was to move any constants on the left to the right. Now this is a regular two-step equation that you know how to solve, but I was just trying to kind of make it structured for you to see. So I do have a constant here, it's the positive 4. I would like to bring that over to the right. So the opposite of adding 4 is subtracting 4. And what I do to one side, I must do to the other side. So I am left now with this 2x. 4 is gone now. Negative 4 minus 4 is negative 8. And don't forget, you're allowed to use your calculators for all this. Okay, now it's just a regular equation to solve. It was at this step too, but I just wanted to give you the steps. Okay, so what's happening to x? We're multiplying by 2. So we have to undo that by dividing by 2. What I do to one side, I do to the other side. So x is going to be equal to negative 8 divided by 2, which is negative 4. X is equal to negative 4. Okay? Now, if you wanted to check, we're not going to check every single one of these in the lesson just because I want to save some time. But if you want to check, you just rewrite your original equation, which was x plus 4 is equal to negative x minus 4. And just like we did when we first learned equations, you can just replace your value of x. This is negative 4 plus 4 is equal to negative 4 minus 4. Negative 4 plus 4 is 0. This turns into a positive. 4 minus 4 is 0. Okay? Okay. Let's try number 2 together. Okay, following the steps. First thing we do is we draw our line and we look on each side of the equation and see if there's anything we can simplify. No. No. Okay, so now my first order of business is going to be to bring any variables that are on the right over to the left. So I see a negative x here. I need that to be on the left side, so I'm going to do the opposite. So it's a negative x, I'm going to add x. If I do it to one side, I have to do it to the other side. So of course I'm going to add it to the 3x, not the 2. I bring down the 2. And this is negative 3 plus x, which will give me negative 2x. Okay, and again, remember guys, if you struggle with your integer rules, you're now in 8th grade, you are allowed to use the calculators. So if you weren't sure, you could always plug into your calculator negative 3 plus 1. Okay, so that's equal to, the x's have canceled out, and I am left with this negative 8 to bring down. Okay. Now our next step was to take any constants that were on the left and bring them over to the right. So I do have this 2 here, but you have to be careful because this minus sign is attached to the 2x. It has nothing to do with the 2. This 2 is positive. There's nothing written in front of it, so it's positive. So to move it over, I'm going to subtract 2 because this is a positive 2. 2 minus 2 cancels out. What I do to one side, I must do to the other side. So that leaves me my negative 2x is equal to negative 8 minus 2 is negative 10. Now I just have a one-step equation to solve. So the opposite of multiplying by negative 2 is dividing by negative 2. What I do to one side, I must do to the other. So this is x is equal to negative 10 divided by negative 2 is positive 5. So x is equal to 5. And you can check that. Okay. All right. I'm going to show you another one here. This is an important example because sometimes when you move your variables over to the left side, you will end up with a negative variable. So I want to make sure you know what to do when that happens. And the answer to that is nothing different. So again, I'm drawing my line. I'm just making sure there's nothing to combine on either side, no like terms to handle. So my first step is to take the variable that's on the left and move it to the right. I'm sorry, to the right and move it to the left. So I need this 2b over on the left. So this is positive. So the opposite of adding 2b would be subtracting 2b. So if I do that to one side, I have to do it to the other side. So you line it up with the like term. And now I have b minus 2b. So that's like 1 minus 2. So that's negative 1b. You don't have to write the 1 though, but I'm going to keep it there for a minute so I can show you what I'm trying to show you. Bring down your plus 4 is equal to, and then this is negative 5. Don't forget that negative that's attached. Okay? Our next step is to move any constants over. So I have this positive 4, so I'm going to do the opposite of adding 4, which is subtracting 4. What I do to one side, I do to the other. And that leaves me with my negative 1b is equal to negative 5 minus 4, same sign, add and keep, negative 9. Now, I need b by itself. Technically, what's happening here is I'm multiplying b by negative 1. Now, if you had left this as negative b, it's fine, but I wanted to show you it with the negative 1 so that you could see that it's really multiplication by negative 1. So technically, you're not done. You still have to get rid of that negative. So what you're really doing is dividing by negative 1 on both sides. But you can also just change the signs, because when you divide or multiply by a negative, you're changing the sign. Okay, so negative 9 divided by negative 1 is positive 9. Okay, and that's it. If you ever end up with an answer such as this, like negative b equals negative 9, you know you're going to have to divide by that negative. So what you can do is just change both of the signs like that, and it would be b equals 9. Just a little helpful hint. Okay. Okay, let's do the last one on this page. 10h plus 12 equals 8h plus 4. So we draw our line and we look just to make sure. No like terms, no like terms. You have to pardon my nails, by the way. Obviously haven't been able to get to the salon. We're gonna move the variables over to the left. So I have an 8h here, that's positive. So I'm gonna do the opposite, which would be subtracting 8h. What do I do to one side? I do to the other side. So this gives me 10h minus 8h, which is 2h. We bring down our plus 12 equals, this is a positive 4. This time we don't have to worry about a negative. Okay, we're going to move any constants over here to the right. So positive 12, I'm going to subtract 12 from both sides. That leaves me my 2h. This is gone now. So this is equal to 4 minus 12, which gives me negative 8. Final step is to divide by 2. We're doing the opposite of multiplying by 2. And what I do to one side, I must do to the other side. So h is equal to negative 4. Okay, and you can of course check that. So the key with these guys is to go nice and slow and make sure you write out every single step. This is what your problems should look like when I check your homework. I don't want to see people multiplying, dividing off to the side. That's not how this works. You got to do it straight up and down so you can keep yourself organized and balanced. Okay, so please don't let me see anything written on the side. You know, 4 minus 12 over here like this. I don't want to see that. I want it to be here, nice and neat, organized, so that you can solve these and they're going to get more complicated. Okay? So for 5 through 8 here, what we're going to do is I'm going to have you pause, try these 4 on your own, and then you can unpause and check your answers, okay? Please try to set it up the way that I just showed you and follow the steps, and you will be successful if you do it that way, I promise. All right, go ahead, give it a shot. Okay, here's the solutions. For number 5, find that x is equal to negative 2. Subtracted the negative 5x from both sides. Careful of the double negatives here. It gives you negative 11x. And we end up with x equals negative 2. Remember to be careful if you have a negative in front of these constants here. You have to bring those down. For number 6, I got a equals 6. This one was pretty simple. Number 7, got to be careful with negatives again. This gives you subtract n, this gives you negative 2n. And then you have to remember to bring that negative in front of the 11 down. So when you solve it, you get n equals 8. And then finally, number 8 was a little simpler. You do have a negative variable, but it's nothing crazy. So you end up with p equals 3. Okay, guys? The last section, what you were supposed to be doing here is writing an equation to represent each relationship and then solve it. But what we're going to do for this is we're just going to write the equation. Because this is a pretty long video already, we're going to just write the equation instead of working through and solving it, okay? So 2 less than 3 times a number is the same as that number plus 10. So when they say is the same as, that's where your equal sign is going to go. 2 less than, remember that means that the 2 goes afterwards. 3 times a number, so let's say 3x, maybe. So 2 less than 3 times a number, so that's 3x minus 2. 2 less than 3 times a number is the same as, that's my equal sign, the number, which is x, plus 10. X plus 10. Okay, and that would be my equation that I could then solve. Number 10, a number increased by 4, that means plus 4, is the same as, that's my equal sign. 19 minus, that means that it's 19 and the subtraction sign's after the 19, 2 times the number, so that's just 2. Okay, so this is going to be, if we use x, a number increased by 4, so x plus 4 is the same as 19 minus 2 times the number, so 19 minus 2 times x. That would be the second equation. Okay, and finally, 20 less than, remember that means that it comes at the end, so it's minus 20. 8 times the number, that'll be 8 times x, is the same as, will be my equals, 15 more than the number, so that's going to be plus 15. Okay, so 20 less than 8 times a number, that's going to be 8x minus 20. 20 less than is the same as 15 more than the number, so x plus 15. And if you wrote 15 plus x there, you would not be wrong. They mean the same thing. Okay, so if you want to go ahead and try to solve these 3, you can. I'm not going to make you do that though, because we do have classwork, homework, whatever you want to call it, to do. Okay, guys, so try to follow the steps. When I check your homework, I am going to be looking to see if you are doing it in the same way that I've taught you to do it, because if you try to solve these equations, you know, in your head, off to the side, etc., it might work now, but when we get into the more complicated equations, which are coming literally within the next lesson and the next, actually 3 lessons, it will be extremely difficult to solve them correctly. So please follow the steps, which is what I've been trying to get you guys to do since we first learned equations. Okay, draw the line, you know, balance the equation by doing the same thing to both sides, etc. Okay, everything all in that one spot, nothing off to the side. Okay, have fun with this.